Hello and welcome once again to Pale Blue Thoughts, your go-to channel for separating fact from fiction and promoting scientific thinking. I have made several videos explaining why Ayurveda is a pseudoscientific form of treatment with no scientific backing. I'm not going into details about it, and you can check out my entire playlist on why Ayurveda is pseudoscientific here. However, this system is quite popular in India, with millions falling for the cheap, under the belt and downright fraudulent marketing gimmicks of certain babas and yogis and gurus. I have also shown with evidences from real studies that Ayurveda is not as harmless and side effect free as claimed by the manufacturers. Ayurveda and other forms of herbal dietary supplements have started to become one of the leading causes of drug-induced liver injuries these days. Of course, I care two hoots about the worthless rubbish that is actually written in the Samhitas, but is it really right to write off Ayurveda just like that? After all, many plants do have chemicals which may have medicinal properties, and even modern science-based medicine uses plant extracts to make some of their medicines. For example, aspirin, the commonly used pain reliever and anti-inflammatory drug, was derived from the bark of the willow tree. Digoxin is a medication which is derived from the foxglove plant and is used to treat heart conditions such as atrial fibrillation and heart failure. Then there is Taxol, a chemotherapy drug which is derived from the Pacific yew tree and is used to treat various types of cancer including breast, ovarian and lung cancer. Finally, we have morphine, the potent painkiller which is derived from the opium poppy and is used to treat severe pain. These are just a few examples of the many modern medicines that are made from plant extracts. So why are you against Ayurveda is a common question that I often get to hear. So I thought I will make a video to explain what promoters of Ayurveda should do in order to make it scientific. Of all the alternate medicine practices, the single one that can offer any sort of hope if utilized properly is Ayurveda. I have absolutely no expectation from homeopathy. That's a clear sham, quackery, deadwood, period. But Ayurveda can yield results if and only if the Ayurveds follow certain principles, and that is what I'm going to describe in this video. I will also share a real life example of how a woman helped save millions of lives by using a drug derived from a plant mentioned in Chinese traditional medicine, which is similar to Ayurveda in many respects. Here is the groundbreaking story of YouYou Tu and her discovery of Artemisinin, the wonder drug for malaria. Welcome to the series Pioneers of Science by Pale Blue Thoughts. YouYou Tu is a Chinese scientist who made a breakthrough discovery that has changed the face of malaria treatment. Her discovery of Artemisinin, a drug derived from a Chinese herb, has saved millions of lives around the world. Tu's achievement has been hailed as a landmark in the fight against one of the world's most deadliest diseases. Tu was born in 1930 in the east coast of China. When she was 15, she contracted tuberculosis, which badly affected her. Luckily for humanity, she survived and decided to pursue a career in medicine so that she could help humanity from diseases that she suffered from. She completed a medical degree from Peking Medical School in 1955. Although she had studied modern medicine, her area of interest was Chinese traditional medicine, on which she did a 3-year full-time course later. Now, Chinese traditional medicine is fraught with pseudoscientific concept, with the majority of its treatment having no logical mechanism of action, just like our Ayurveda. It uses such concepts as yin and yang and qi as its vital force. TCM also has plant and animal-based so-called medicines such as rhinoceros horns for treating erectile dysfunction and flawed systems of treatment like acupoints, acupuncture, cupping, etc. The Chinese government, however, claim that TCM is a science and continues to encourage its development, just like our dear Ayush ministry in India. Malaria is a mosquito-borne disease caused by a parasite called Plasmodium. It is spread exclusively through bites of infected Anopheles mosquitoes. The mosquito bite introduces the parasites from the mosquito's saliva into a person's blood. The parasites travel to the liver where they mature and reproduce and causes malaria. It is prevalent in tropical and subtropical regions including Africa, Asia and South America. The disease causes fever, chills and flu-like symptoms and can be fatal if left untreated. According to the WHO, there were an estimated 229 million cases of malaria in 2019, resulting in 409,000 deaths. The majority of these cases and deaths occur in sub-Saharan Africa, where the disease is most prevalent. You can check out the eye-opening video that I had made on the most dangerous insects called mosquitoes over here or in the description box below. In the late 1960s, new strains of malaria became resistant to existing treatments like chloroquine. The global medical community struggled to respond in a timely manner and the disease quickly spread, killing millions of people. That was a time when the Vietnam War was in progress and the malarial outbreaks were especially disastrous to both sides fighting the war. In 1964, malaria caused 4 to 5 times more medical disabilities among US military forces than due to direct combat. As a result, tackling malaria became a top priority for not just the warring countries but for the entire world as a whole. It was during this time that the Chinese government established a secret program codenamed Project 523 to find a cure for malaria. YouYou Tu, who was a young researcher at the time, was selected to be part of the team. The team's mission was to find a drug that could cure malaria and that it should be safe and effective. Tu spent years studying ancient Chinese medical texts and searching for plants that could potentially cure malaria. Professor Tu's group started with a search for recipes that had been used to treat fever. They searched more than 2,000 recipes and compiled 640 recipes for further evaluation within 3 months. They then looked at the individual plant names that had high frequencies of appearance in the recipes. A plant called Artemisia annua, or qinghao as it was called in Chinese, was one of the plants that appeared in the recipes frequently. Now Tu had one thing that was different from other proponents of alternate medicine. She had a scientific temper. So she conducted trials on rodents and also insisted on the extraction of the active ingredient than using the whole plant. The first experiments did not prove very successful as the extracts were not stable. The variation could have been due to many factors, including geographic origins of the plant, seasonal variation, different parts of the plant used, and the methods used in extraction. Tu and her team understood this and worked tirelessly to extract the active ingredient from sweet wormwood. In 1972, she came across a reference in a book written in 400 CE by a person named Gi Hong, which referred to sweet wormwood, a plant that had been used in traditional Chinese medicine for centuries to treat fever. Tu believed that the plant's active ingredient could potentially be used to cure malaria. In that book, Gi Hong had described how to obtain the juice from qinghao plant to treat fever using cold water instead of the traditional methods of boiling herbs for preparing Chinese medicines. Professor Tu suddenly realized that high temperature could be the cause of instability that they had experienced. The second hint Professor Tu had from Gi Hong's description was that the plant leaf was likely the part having the most activity because the juice could be obtained from the leaves much easier than other parts of the plant. She decided to use ether replacing ethanol to extract the active ingredients from the leaves of the plants. The reason for that was that ethanol had a higher boiling point than ether, so when ether was used in the extraction, this greatly improved the stability of the active ingredient. And finally, after failing 190 times, Tu and her team obtained a sample on the 191st try that could inhibit rodent and monkey malaria with a 100% success rate. The process may have been challenging and time-consuming, but after several years of research, they were able to isolate the compound that would later be called Artemisinin. This was then purified before it was used as a medicine. Professor Tu presented her work at a meeting held in Nanjing on 8th of March 1972. Her results were exciting, and the leadership of Project 523 decided that she should conduct a clinical trial in the same year. Tu herself became the test subject by taking the medicine herself to test its safety and efficacy. However, unlike her dear old Samuel Hahnemann, she had a better scientific sense. In August 1972, Professor Tu led a clinical trial team and tested her extracts on 21 patients, achieving 95 to 100% inhibition after taking the medicine. And before you ask, yes, she used a control group who were given chloroquine. Tu's discovery of artemisinin was not immediately recognized by the scientific community. In fact, it was initially met with skepticism and resistance, but natural. But her experiments were repeated by scientists in the medical field. Artemisinin was shown to be highly effective in treating malaria, even in cases where the disease had become resistant to other drugs. And in the 1980s, artemisinin was approved for use in China, and in the 1990s, it was adopted by the WHO as a recommended treatment for malaria. Artemisinin has since become a key weapon in the fight against malaria. It is now widely used in combination with other drugs to treat the disease and has helped to reduce malaria mortality rates around the world. Following the demonstration of anti-malarial activity, her group continued to isolate the active ingredient of white crystal, which they named Qinghaosu. The isolation of the crystal allowed further investigation of its chemical structure. She also coordinated with scientists in Beijing and Shanghai and played a role in determining the structure of artemisinin using the crystal that they had obtained. Professor Tu also discovered dihydroartemisinin that greatly improved the water solubility of the chemical and enhanced its treatment efficacy. Tu's discovery has been called the most important pharmaceutical intervention of the last half of the 20th century. In 2015, Tu was awarded the Nobel Prize in Physiology or Medicine for her discovery of artemisinin, becoming the first Chinese woman to win the award. Tu's discovery of artemisinin is a testament to the power of scientific research and the potential for traditional medicine to inspire new treatments. Her work has saved countless lives and has helped to transform the way we think about and treat malaria. Tu's legacy will continue to inspire scientists and researchers around the world to tackle the world's most pressing health challenges. Hats off to you, YouYou Tu. Now let us see the parallel between what Tu did and what happens in our country with Ayurveda, our very own traditional medicine system. It is quite clear that Ayurveda is pseudoscientific, as its theory and practical are both based on unscientific principles. Ayurveda still revolves around the outdated humoral theory of Vata, Pitta and Kapha, which has been chucked in the garbage pile by science. But Ayurveda can learn from YouYou Tu and make itself scientific. Here is how. Number 1. Chuck the humoral theory and adapt to modern scientific principles. I know Ayurvedists learn many modern medical systems during their BAMS. I urge them to forget the slokas and concentrate on the scientific theories. I know it sounds simple when I say it, but if the humoral theory is discarded, there might not be Ayurveda, but that is required. Tu didn't rely on the humoral theories of TCM while performing her experiments. She used a scientific approach to extract the key ingredient from a plant. Now, can Ayurvedists do that? It is not impossible, right? The money is there, the manpower is there. It is just the will and perseverance that needs to be developed. Alas, I forgot the key active ingredient for having that: having a scientific temper. Number 2, realize the fact that everything in this world is not made for humans. Plants are not beings that have been created to make medicines for us. They do not. They make chemicals which enable them to survive in the world and ward off their attackers. Evolution has given them this ability since they can't run away from their predators like animals can. So a single plant can have millions of chemicals, all of which might not be useful for humans. Some might be useful, but many might be detrimental for our health. This is the reason why I mentioned earlier that herbal concoctions are the rising cause of drug-induced liver injuries. These poisonous chemicals need to be detoxified by your liver and kidneys, and that can take a toll on these poor, hard-working organs. Do what Tu did. Find the exact key ingredient that is useful. Number 3. If you can't discard Sushruta and Charaka, don't. Keep them close to your heart, but keep them there. Don't send them to your brains. Just find out the key active ingredient if you can from the plants that they have written about. Just spare the elephant dung, civet cat and crocodile semen, bile of lizards and the urine of cows and elephants and horses and such, please. Just don't boil the whole plant, tree, stem, bark and roots and make a kashaya. Do what Tu did. Find out the right extraction method. Boiling may not be the best method as shown by Tu. Find the correct method. Science has developed very good extraction methods for chemicals these days. Use the technology that is available to you, which Tu did not have. Extract only the wanted ingredient. And for your heaven's sake, purify your extract. And don't you dare use milk or cow dung or gomutra for it. Use what science suggests. Do what Tu did. Once you have identified the key component, then you can spare the trees and plants. The same can be synthesized within a lab like Tu did. Do your bit to help the environment. Fourth, conduct research. Conducting rigorous scientific research studies is crucial for validating the safety and efficacy of Ayurvedic treatments. Ayurvedic practitioners can work with research institutions to design and conduct randomized controlled trials, systematic reviews, and other types of scientific studies. It is not rocket science. Science has been doing it for years now. And please ensure that you work with control groups when you do your randomized trials. Without a control group, all your research is useless. Do what Tu did. Conduct proper clinical trials with control groups. If at first you don't succeed, try again. Remember, Tu found a treasure on the 191st try. Next, conduct safety trials. The reason why Ayurvedic medicines are a major cause of drug-induced liver injuries are because the proponents don't conduct safety studies. The first step to understand if there are any side effects for a chemical is to study its effect and side effects. If that step is skipped, then you will not know if there are any. It is like hoping to pass an exam by skipping to study for it. Ayurveda claims to be side effect free only because they don't conduct trials to find out if there are any side effects. Almost all chemicals cause unwanted side effects when they interact with other molecules they don't gel with. And our body has millions of molecules of different kinds. So the chances of a contraindication is rather high. And it's okay to have side effects if the benefits outweigh the risks. And through continued research, you will end up getting better treatment methods with less harmful side effects. Modern medicine has something called pharmacovigilance, which constantly monitors harmful effects of medicines even after it reaches the market. Adopt that practice. Going further, standardized practices. Ayurveda has many diverse practices and therapies that vary across regions and practitioners. Standardizing practices and treatment protocols can help ensure consistency and reproducibility of results, making it easier for practitioners to compare outcomes and evaluate the effectiveness of treatments. If you want to continue your Panchakarma treatments for earning some extra money, go for it. But don't advertise that it can cure diseases or is effective for any disease conditions. Market it just like Thai massage. There will always be gullible rich people who would get an endorphin high through a massage, and they will pay you handsomely for it, and you will get your happy ending. Moving on, emphasize evidence-based practice. Ayurvedic practitioners should place greater emphasis on evidence-based practice, relying on high-quality research studies to guide their treatment decisions. They also should be open to updating their practices as new evidence emerges. Don't go with the random notion that a particular plant extract could be your next medicine. Shushda and Charaga could have been wrong. Experiment with various molecules. Do what Tu did. Publish your findings in recognized peer-reviewed journals and not in obscure, unheard of, confirmation-biased predatory journals. Do not cheat and do not manipulate data to fit the conclusion that you want. Do not follow the evidence. Let evidence lead. Collaborate with modern medicine. Ayurveda can complement modern medicine provided you do it using the scientific method. Once you have adopted the scientific method, then your medicines would no longer be called alternate medicines. Your medicines will be called just that, medicines. Don't you want your medicines to be sold as medicines instead of the current dietary health supplements? If your real wish is to help humanity, then your ego need not get hurt if your medicines become part of modern medicines. You will be recognized for your contribution, and the next Nobel Prize might be sitting on your showcase like it did for Tu. So do what Tu did. Ninth, enhance education. Ayurvedic education should include a strong emphasis on scientific principles, research methodology, and evidence-based practice. This can help ensure that Ayurvedic practitioners have the necessary knowledge and skills to apply scientific principles in their practice. Teach the students how to analyze evidence and not by heart the slokas. Take only what passes through the scientific trials and dump the rest of the slokas and other rubbish notions in the ancient texts into the nearest landfill. And finally, don't get your high on nationalism, tradition, parampara, anushasana and pradishta, sanskar, or gloat over the ancient wisdom of our munis and saints. We know more than them, all thanks to science. Do what Tu did. Sticking to an evidence-based approach, proper control-based clinical and safety trials, and a proper pharmacovigilance process can give better credibility to your treatment system. By incorporating these suggestions, Ayurvedic practitioners can make the system of medicine more scientific, ensuring that Ayurveda continues to be a relevant and effective system of healthcare in the modern world. Whether any Ayurveda is going to listen to my suggestions is anyone's guess, but my advice to them is still, do what Tu did. I hope you liked this episode. Please share, like and comment if you did. You can support me by using the Super Thanks button or using the Buy Me a Coffee link in the description. I shall be back soon with more scientific content. Until then, it's bye-bye from Pale Blue Thoughts.